How's everyone doing? In this episode, I'm going to show you how to create a unit circle using cosine and sine. Actually, the sine is y corresponding to y, and cosine is corresponding to x, and then they form like a coordinate point. That point is composed of x and y coordinates. So first we just quickly create this unit circle, and then we break it down into its constituent parts and do a little bit of analysis, animation, and using Python, and then move on to first we generate the static plot using Python, and then using the iPad widget to have an interactive one, and then we animate it. It's like escalate layer after layer. So first we need to just start quickly. We set the interval between the two adjacent row at 0, 1, because we need to have a smooth curve. However, if there's we just pass in like not many, just 0 and 0.1, because we need a smooth circle. The curve must be smooth. If we pass in like maybe half, maybe just several data points, you definitely won't look like even a circle. You will look like a polygon, because you have flat like sides instead of curves. So in this column we can just convert this radians into degrees. It's actually a little bit redundant because it's just for reference. For example, if we move on to the around 90, you can see it's just 3.14, and then divide by 2 around this area. So then we can calculate the x using the formula. First we grab the radius, and then we times cosine. After that we pass in the radiant, and of course we need to use the dollar sign, double dollar sign. First dollar sign is for the log of the column, and the second is for the row. So because this cell is reside in the E column and row 2, thus we pass $2 signs to lock it there. It won't be shifted if we drag down. It won't be shifted like this one. We have two solutions to achieve the same result. The first is to just lock it down. While you drag it down, the first reference, like always, refer to this one, because we need to drag in the pi, the radian value, when it's forms a dynamic when it's moving down. However, the radius needs to remain put. That's why it is. Or you can have an entire column populated with a 0 like this. You don't need to lock the cell down. However, either way works. So we can drag it here, drop it here, and then the first cell we don't need to have any don't need to change or alter anything. We just pass in the radiant, and then because we're now referring to the y coordinates, so we just change to sine, and then we drag it down. So it forms a circle, and right after that, maybe we just highlight it using green background, and then it's consistent. We can first have a look at it. For example, if the x is the 0.36 corresponding to this spot, so you have a y value 0.93 that forms this spot, because a data point, if we plot it, it's like a scatter plot plotted around. It forms a circle. Thus, each individual point is a data like an entry a pair of coordinates, x coordinate, y coordinate, and forms this spot here. Anyway, because it's a unit circle, it's very convenient. Any value can be directly, you can assign it. For example, if you're referring to the hypotenuse, it's definitely hypotenuse equals radius. So here we can just write something down. So hypotenuse equals the radius, and then it's easier for you to calculate the sine, the y value. The y actually, for example, in the vertical line here is actually the sine value. It's just the you use the radius is the hypotenuse, and then you times the sine, and you have the y value, and the x is the same, follow the same logic. You use the hypotenuse, and then you just use like a parallel line, you drag it down either here or here. So when we form a bounding box, just imagine this as a bounding box. This confines it. It's like you're shining a light here in this direction. For example, now we're talking about the y value, so we have a light source that is positioned at the left side. So there will be a shadow or silhouette that is projecting at this area. You can also imagine it like this, because we have a parallel vertical line. If you shine a light at this direction, and of course it has the same length. The length is the same, and let me clear this. If on the other hand, if you shine a light from top or from this area, you have the horizontal line. They are identical in parallel, and the length is identical. So that's how it is. It is the x coordinate, y coordinate. Because it's a unit circle, I guess this is more of an oval, because I don't, if I drag it, I need to readjust everything, so just keep it. Of course, you can imagine that as a circle. So if like the radius, hypotenuse is overlapping with the radius, then we have this coordinates is definitely corresponding to this row, Maybe we can change the color a little bit for better visualization. The font color is brown, so here you have a x that is overlapping with the radius is actually 1. That's x radius. Hypotenuse, because the radiant is 0, so there's a definite 0. So, and y is actually 0 because there's no movement, no shift in the vertical direction, so the definitely is 0. For example, if we move a little bit maybe like this, corresponding to this, but this is can be a little bit confusing because we didn't increase the accuracy. It's not as we only kept 2 decimal places. If we need to be precise, it should be like this. So we can maybe adjust a little bit for a quick adjustment. Otherwise, it might be a little bit confusing, but you can imagine it. There's some differences. So if we just change it, maybe we're referring to this one. It's the same, just a tiny movement here. You have 1, you have 0.9, just a little bit in the y direction. So that's how it is. Now we have corresponding like a plot here. Is actually why the sine and cosine forms a circle is because the overlapping of the original point and the ending point. For example, you complete a whole circle, you ended up here. at this point is actually, you can imagine it starts from 0, the radiant, and you end up around 6.28, that is 2 pi, and you convert it to the degree is 360. I guess I need to drag it down here at least. Let's see. Oh no, I need to drag it down here. That's a 360, and we also need to be more precise. So it's a full circle here, full circle, because just one spot maybe not that significant on the visual effect. So after that, after the adjustment, is a full circle here. You have a 0 starting here. It's a 1. We just saw it, and it's like we're dragging this. Just imagine this as a handle on how can I say it, on the watch. You have this, you walk around, and then boom, you landed here. It's also, this is, you can imagine the degrees of 360, and corresponding to the pi radian value is 6.28, and the pi is 2. So so this is how it works. And then this is the expansion of it. We just expanded. This is the overlapping, this is the expansion, and we can have a quick look at it. You have a sine, because here's the pinnacle and there's the valley, and we shift it and let it overlap. It just forms a circle. And then if we just shift like a 1 diameter in terms of the circles. Okay, there's a quick rundown of the Python version. You can first just this is actually what's already been rendered in the Excel file, so we just read it in using pandas, and then have a quick look at it, and then have a sense of it, and then plot it out. Because this sine and cosine is separated because we didn't specify the x and y, and if we specify it, it forms a circle. Here's the first one, and then we can have an object. Maybe we can quickly create a circle, and then using sine, cosine, and here we have a little bit control. I guess in this rendering we have a little bit of it's a little bit slow. Maybe we can move on to other stuff, maybe to this one. This is also a rendering. Animation, you can have an animation of it. Just several steps. You first created the axis, and then you plot it out to have a sine function, numpy sine function, and then you create it to get the curve, get the area under the curve, and then you have a label, get a label and read it out. This is how it's rendered. The using Manim library, you can also create it. It seems stuck. Yeah. Then you can also use the simplified to render it. Simplified is similar. Simplified just you use the formula and all the input. Of course, you can use a scatter plot, and this is a little bit interactive because we can have a little bit control of it. If you want only one quadrant to show up, then maybe a little bit of less sparsely populated. Okay, like this, then you can see clearly because we're reducing the points, how many points we are giving. And for example, if we reduce the data points to 10, you can definitely see it's not a square, it's not a circle, it's actually a polygon, and you have a flat sides. And if we start to increase it, you gradually taking the shape of a curve, and then it definitely is a circle now. Or if we bump up the number of points from initial to 50, and you have a inverse relationship because it's divided. If you want to have a 4 quadrant, then you just dial down to 1, and then you want to increase it, then you have less quadrant. Thank you.